Welcome to the review session for the Operations Management 726 midterm, and we are doing problem number 7, which is a process conformance problem in the quality section. So what is the capability of this process? We are looking at a company that has a specification for the product, and the specification is 1 inch plus or minus 0.05 inches. Let's assume that this is a metal part and the 1 inch is the length, so we need little pieces of metal that are 1 inch long, and it allows the variation at the lower end, so the lower specification limit can be 0.95 inches because that's 1 minus 0.05, and anything in between that, certainly the 1.0, that's the target, is fine, all the way up to the upper specification limit of 1.05 inches. This is the distance that we can have a product length and have it be good. So that's what this means. So what you should realize is that this question is really asking about process capability. It says there's 2 machines that can make the part. They each have a mean of the part that they spit out, as well as a standard deviation, and is either one of these 2 machines capable? So to do this, we use the formula for process capability, which is written as big C little p, so capability of the process. And that equation, which you should all have on your cheat sheets for the midterm, is the distance between the upper specification limit minus the lower specification limit. That's the numerator of our equation, and the denominator is 6 times the standard deviation of the process. Sometimes this is written with the Greek letter sigma, which looks like this kind of, and it stands for the letter S in the Greek language for standard deviation. And so if this is the numerator, the distance between the lower specification limit and the upper specification limit, what we're doing is we're comparing that distance with what is the distribution of product made by this process. And we would represent that distribution with a normal distribution curve, and it's going to have some mean. Let's assume for a second that it's centered, that this U stands for the mean of the process, and that it is centered on the mean of what we want. That is the case with machine 1 and machine 2. They are centered on the mean. And we know from the normal distribution curve from our statistics class that 50% of the product is going to lie minus 3 standard deviations from the mean to the mean, that this half of the curve will be 50% of the product, and the other 50% of the product will be the mean plus 3 times the standard deviation of the product. So nearly 100% of the parts made by this process will fall within an interval that is 6 times that standard deviation of the process. That is what is the denominator of our equation here. And so what this equation is saying is if the specification limit, the numerator, is bigger than the normal variation in the process, which is the denominator, then the numerator is bigger than the denominator. What kind of ratio is this? That's going to be greater than 1. And a greater than 1 CP then is therefore capable. It's capable because the specification is bigger than the product process distribution. If instead it looked like this, where the process distribution was bigger, plus or minus 3 standard deviations of the process is falling outside of the lower and upper specification limits, then the denominator is going to be bigger than the numerator. And if you have a bigger number in a denominator of a fraction than the numerator, then it would be less than 1 as this ratio of CP, and that would be not capable. Now we could consider something exactly equal to 1 as being capable as well. So this is the formula. Now we have to use this formula in this thinking to determine if machine 1 or machine 2 or both of them are capable of meeting this specification of 1 plus or minus 0.05 inches. So let's look at machine 1 first. So machine 1, the mean is on the mean of the process, so we're just going to consider the standard deviation of 0.025. And what we know is we know that 3 times that standard deviation needs to be less than 0.05 inches. Okay? So 3 times the sigma is equal to, should be less than 0.05 inches in order to be capable. So for machine 1, that is 3 times 0.025, which that is equal to 0.075, which is greater than 0.05. So machine 1 is not capable. And if we look at machine 2, 3 times the standard deviation of machine 2, 0.015, that is equal to 0.045, which is less than the 0.05 that we're allowed. And so therefore this machine is capable. Machine 2 is capable. We could come to the same answer using this equation. So the upper specification limit is 1.05 and the lower specification is minus than 0.095. And we divide that by 6 times the standard deviation. So for machine 1, it's 6 times 0.025. And if we were to do this out, this difference here is 0.10, and 6 times 0.025 is equal to 0.150. So we know that 0.1 divided by 0.15, that is less than 1, and therefore this is not capable. Okay, the actual number turns out to be 0.667, which is less than 1 and therefore not capable. So this is machine 1's CP. And if we were to do machine 2's CP, we have the same numerator, so 0.1 in the numerator, but the denominator now is 6 times machine 2's standard deviation, which is 0.015. So that's equal to 0.1 divided by 6 times 0.015 is 0.09. So we know by looking at this that 0.1 is bigger than 0.09, and therefore this is going to be greater than 1. And actually it's 1.11, which means that it is capable. So again, machine 2 is capable. Thank you very much, and good luck on the midterm.